folks. Okay, so here are some derivatives. We have a table of values here. We have some function values and we have some derivative values for -1 and 2. And we have some functions. We'll have some normal derivatives, some product rules, some quotient rules, some chain rules, and whatnot. So therefore, we just want to take the derivative of this function and evaluate it at -1. So the derivative of f is f prime of x, and we're going to plug in -1, so 2 times f prime of -1 is equal to 2, so 2 times 2 is equal to 4. Here we need to take the derivative using the quotient rule, which is, quotient rule would be low d high f prime of x minus high d low all over low squared. So it would be g of 2 f prime of 2 minus f of 2 g prime of 2 all over g of 2 quantity squared. So g of 2 is -1 times f prime of 2 is equal to 1. F of 2 is equal to 2. G prime of 2 is -5 all over g squared, g of 2 squared. So that's -1 squared. So this is -1 minus a -10 all over 1. So that's -1 plus 10, which equals 9. Our next problem here is the same table of values, just rewritten so I can see it. Here we're using the chain rule. Well, the chain rule says you take the derivative of the outer function, rewrite the inner function, multiply that by the derivative of the inner function. So we get f prime of g of -1, g prime of -1. Well, g of -1 is equal to 2, so I get f prime of 2. G prime of -1, g prime of -1 is -3 times -3. F of f prime of 2 is 1 times -3, which is equal to -3. Here we have the square root function, the square root of f of x. So I'm going to rewrite it as f of x to the 1/2 power. The derivative of that would be 1/2 f of x to the -1/2 times f prime of x. We plug in 2, we get 1/2 f of 2 to the -1/2 f prime of 2. So f of 2 is 2 to the -1/2. F prime of 2 is 1. So I get 1 over 2 times the square root of 2. Here we have a little quotient rule situation. So the quotient rule says low f of x times the derivative of the high, which is g prime of x, plus 0, derivative of 2 is 0, minus high times the derivative of low, which is f prime of x, all over the low squared. So we're plugging in -1, so it's f of -1, g prime of -1 minus g of -1 plus 2, f prime of -1, f of -1 squared. So I can't see my table of values. Let me move the page up a little bit. Okay, so f of -1 is -1 times g prime of -1 is -3 minus g of -1 is 2 plus 2, f prime of -1 is 2 all over f of -1, which is -1 quantity squared. So I get 3 minus 4 times 2 all over 1, which is 3 minus 8, which is equal to 5. Here's our last example. Let's rewrite it again since I have a radical as f of x plus, f of x squared, g of x squared to the 1/2. So the derivative of the outside is 1/2. Rewrite the inside. Times, the outer function in this case is 2 times the inner function times the derivative of the inner function. This is all just a derivative of f of x squared. The 2 comes down, multiplied by the inner function f of x, multiplied by the derivative of the inner function, which is f prime of x. Derivative of this one is the same thing. 2 times g of x, g prime of x. And I forgot the negative 1/2 here. So we rewrite it as f of negative 1 squared plus g of negative 1 squared to the negative 1/2 times 2 f of negative 1 f prime of negative 1 plus 2 times g of negative 1 g prime of negative 1. So I get 1/2 f of negative 1 is negative 1 squared plus g of negative 1 is 2 squared. 2 times f of negative 1 is negative 1. F prime of negative 1 is 2. G of negative 1 is 2. G prime of negative 1 is negative 3. This is to the negative 1/2. Keep forgetting that. So I get 1/2, 1 plus 4 to the negative 1/2. I get negative 4 minus 12. 4 times 3 is 12 with a negative. So I get 1/2, 5 to the negative 1/2, negative 16. So I simplify that. This cancels with this. I get negative 8. So I get negative 8 over the square root of 5.